Hello, Assalamualaikum. My name is Nur Amira Nadia binti Razali. So today I'm going to present about my proposal on synthesis and characterization of aluminium oxide by using a combustion synthesis method. For intro, aluminium oxide, also known as alumina, which is famous with high hardness, excellent thermal stability, electrical insulation and chemical inertness. So this aluminium oxide have various applications, which is in fields including ceramics, electronics, catalysts, abrasive refractories and biomedical materials. So this aluminium also exists in a lot of phases, which are alpha aluminium oxide, gamma aluminium oxide and beta aluminium oxide. So the picture is the powder version of aluminium oxide. The next one is the objective of this proposal. The first one is to synthesize the pure aluminium oxide materials using the self-propagating combustion method (SPC). So the second one is to characterize the materials using various instruments, which are thermogravimetric analysis (TGA), X-ray diffraction (XRD), and scanning electron microscope (SEM). So the last objective is to study the band gaps of the aluminium oxide materials via UVBs, which are ultraviolet visible spectrophotometry. The significant study of this proposal of this research is synthesizing the aluminium oxide materials using the SPC, self-propagating combustion methods. So the advantages of this research is the simplicity and cost effectiveness in the synthesis of the aluminium oxide materials. It also provides insights into the relationship between calcination temperature, phase transformation and properties of aluminium oxide materials, which can enable the optimizations and tailoring of aluminium materials for various applications. So the phase transformation behavior of aluminium oxide materials can contribute to the fundamental understanding of phase transition in oxide materials. So this knowledge can have a broader implications beyond aluminium oxide and can be applied to other oxide systems. So it advancing the field of material science and providing insights for the design and synthesis of novel materials with tailored properties. So there are three phases of aluminium oxide. So this is the picture of the phases of the aluminium oxides, which is alpha aluminium oxide, gamma aluminium oxide and beta aluminium oxide, which have different functions and applications in oxide systems. There are three methods, which are combustion methods. So combustion methods is the self-propagating combustion process (HPC), which is a lot of materials in both bulk and nanoscales. So there are few combustion agent we use, which is urea, glycine or citric acid is added along to the solvent, which to dissolve the starting ingredients to start the combustion process. So the next method is sol-gel method. Sol-gel method is for producing a various nanostructures, in particular metal oxide nanoparticles. So this procedure, the molecular precursor is dissolved in water or alcohol and then heated and stirred to form until it form a gel solutions. So the last method is co-precipitation methods that used to synthesize the aluminium oxide under annealing temperature effect. So the crystalline phase and purity for the prepared powder, which is aluminium oxide, will be characterized by different spectroscopy techniques, which is co-precipitation methods using many starting materials. So for the characterization of the aluminium oxide, we use obviously 4 instruments. The first one is XRD, X-ray diffraction. So we use XRD to characterization our materials, since many researchers include this technique to determine the crystal structure of the materials, which aluminium oxide has a crystal structure. So the next one is a thermogravimetric analysis TGA. So this TGA should be used to analyze the thermal stability of aluminium oxides. So many researchers have done this, and the result is not to be disappointed. So we use this instrument for our research. So the next one is scanning electron microscope, SEM. So the ability of this SEM is to provide a clear picture and size and the morphology of the samples that have many researchers before this to characterize their materials. So we will use SEM to characterize our aluminium oxide. So the last one is ultraviolet visible spectroscopy, UVBs. So UVBs is used in this research to characterize our created nanoparticles because it is known for its quantitative measurements. So numerous research have used UVBs with other tools to and analytical techniques that can determine the structural and physical characteristics of their samples. So we will be use UVBs to characterize our aluminium oxide. So that's all for my presentation for my proposal. Thank you for listening.